And with this, I would like to kind of introduce what we try to do within Material Digital in this focus area workflows, because Material Digital has multiple focus areas, and one of them is specifically dedicated for workflows. As I tried to tell you, what are with the challenges we face. So the basic mission statement you see here, what is really important is the bold statement. So we try to combine different software tools and to make those steps of simulations accessible, interpretable, storable, and reproducible. But not only simulations, but of all data handling, data processing, and even experimental processing steps. So that basically, if you have a method that people can redo or reproduce what you have been doing, and also that you yourself can redo this and scale it. So basically, we have not only the computational workflows where the background that Tilman and our group has basically is coming from, but we also try to extend this to experimental processes and also to data transformation, which nowadays everybody who's basically using a computer, you have some kind of data acquisition or transformation happening, so everybody can make use of workflows to capture what they are doing in our understanding. Exactly, and within Material Digital, we try to do this with those two different workflow management frameworks. One of them is mostly coming from KIT, and I'm the representative from the workflow focus area for SimStack, which is a graphical editor, more for drag and drop, so it's easy to use, but it has some limitations of flexibility. And the other one is PyIron, which is mostly developed at the Max Planck Institute for Sustainable Materials, but also Tilman, who's now at the BAM most of the time, he's kind of representing this step. And this is more a really flexible IDE where you have with Python a lot more fine-grained control, which has a slightly higher learning curve. But the idea for both is the same. You kind of capture what you're doing and then make it available to others. So we as a working group have offered something to the community, and what we see in our contribution is basically, so we provide space for discussions on how to solve project-specific requirements, create awareness of what are workflows and how I should use them, how give conceptual support on how to integrate this into given environments, provide demonstrators on those kind of workshops and trainings, what we're doing right now, using SimStack and PyIron, but also try to kind of deal a little bit into this LLM-related topics. We try to help with assisting with integrating software tools into the workflow frameworks and provide a workflow store, which we cover in more detail later on, but also provide basic infrastructure to test those kind of things. And for those who are aware of this, now there's a lot of drive going to also bring this to the European level with Material Commons, and there we also try to help integrate those efforts into Materials Commons. If you want to join, we have our contact form on our website. There's a workflow-specific subgroup, and of course, we also meet in person sometime for even more direct interaction, as you see, like the last workshop in Berlin. But it's not only us who try to work on workflows, but within the Material Digital Funding Initiative, there are a lot of projects who are supposed to try to bring those concepts to specific use cases or materials. And you see here like an overview of all the projects within Material Digital. So there has been a first funding phase from 2021 to 2024, which was mostly academic-led. And then with the second funding phase, which is still ongoing, that's going to go on to industry. And the third one, which is also then picking up more circular economy, which has started. We have like over 200 people from 53 different institutes, which focus on their material class and processes and are supposed to act as mediator into their communities. And they all have different digitalization approaches. So some focus more on the ontological description or how to use the data acquisition and handling. Some do the modeling like we are doing, or others just do simulation or handling of data. And what we kind of expect from those, in the focus area workflows, that they are basically the domain experts who know how to use the software tools that they are using and provide their insights on what needs to be integrated into those workflow environments, that they are the multiplayer in their community, that they bring their experience on how they use the software for simulations, maybe make workflow nodes or provide the semantic interoperability layer, but also how to connect to experimental tasks, like how do I integrate this into the experiment into a workflow environment? How do I use an electronic lab notebook in this context? Or how do I use a device software? And of course, we also would like from them definition on the requirements for workflow. So what do we need to adjust in our workflows, the software that makes it usable to them? And this has been, since we are already doing this since quite some time, there has been a special issue in advanced engineering materials on the topic. And in the first paper that's published here, there was a contribution from the first phase projects mostly. And there they highlight what they are doing with the different topics. So in this table, we try to kind of bring together what the aspects are. So we have this color code, which kind of states if they are more dealing with data handling or data processing, or if they are doing more simulation. And then we have the different topics which we see as important for the workflow environments, like how to connect to HPC resources, so high performance computing, how helping you record your data, providing a user interface, provide interoperability or optimization, or some storage of data, or even the semantic integration. So these are like the topics we try to address and show which of the projects were interested in which of those topics. And just to give a brief overview, what kind of those were like. So we had one example, which is DMAT, which was focusing on additive manufacturing with electric arc laser sources. And they had this calcified phase field simulations and FEM simulations within their project. And they had also a custom software tool, which was MicroS. And they implemented this. So they first captured on what they are doing with this MicroS thing, where defining the inputs and outputs, and then they provided the SimStack and Pyron workflows for this workflow, for this micro simulation, which are now available in the workflow store. So they were a lot closer to us with the simulation code, and they also showed how to basically use our tools to make it available. And another project would be then the Digit Rubber project. And they were focusing a lot on a quite different topic for them. So they were dealing with the rubber extrusion. So they had a lot of sensor data from like a pipe processing pipeline and wanted to real-time control how those rubber extrusion is done. And they had were more dealing with integrating on how to create Arduinos or live sensors into their workflow. And this is also shown in this paper.